Hi, I'm ROSHAN S, 24BME1028, and my topic is equilibrium of rigid bodies in two dimensions. Here the question states that two crates, each of mass 350 kg, are placed as shown in the bed of a 1400 kg pickup truck. Determine the reactions at each of the two rear wheels A, front wheels B. So in this question, we have to apply the equations of equilibrium. That would be f of x is equal to 0 and f of y is equal to 0, and moment about any point should be 0. Here we need not use f of x as there is no force acting in x line. So considering only f of y equal to 0 and moment about any point equal to 0 would be fine. So these two crates are placed on this truck, and the mass of this truck is concentrated at point G. With two rear wheels, so the normal would be 2B, and here in the rear wheels, it also has two rear wheels, so it would be 2A. And here the mass of this carton we know is 350 kg, so it's going to act downwards. The mass of this is going to act downwards, and the mass of this truck is also going to act downwards. So 350 into 9.81, we'll get 3,433.5 Newton. On converting this into kilonewton, we move it by 3 decimals. So we get 3.4335 kilonewton. We'll consider this to be W, the weight of the crates. Now for the mass of the truck, we have to calculate the weight of the truck. The mass of the truck is given in the question to be 1400 kg. So on multiplying it with 9.81, we'll be getting 13.734 kilonewton. Now we have to calculate the moment about any point. So at the force at B is considered to be this way, 2B, and here 2A. So here it will be W of truck, and this is going to be W. Also this will also be W. Now to calculate the moment, so we know the mass of this car about the point G. We'll have to find the distance of the force C and force D. To find the moment about point P, the force is WT is having a distance 1.2. The force A is having the force 2A is having a distance of 1.8 plus 2, that will be 3 meters. So if this is going to be 0.75, this will also be 0.75. So this distance of this D carton from point B would be 2.8 minus 0.75. That would be 2.05. So the distance between C carton and point B will be 2.05 plus 1.7, 3.75. Now let's calculate the moment. Now we'll consider it to be an anti-clockwise moment. So it is positive. Summation of moment at point B equal to this 2A is in clockwise direction, that is in upward direction. So it's opposite to what we have considered. So I can take it as minus 2 into the distance 1.8 plus 1.2, 3 meters. Now the weight of carton T to point B will be 2.05. So 2.05 plus weight of carton C into this distance 3.75. 3.75 plus weight of the truck into the distance 1.2. On calculating this, we will get A is equal to weight into 5.8 plus weight of truck into 1.56. If you are going to calculate this, we are going to get, substituting the value of weight, 3.4335 into 5.8 plus weight of the truck 13.734 into 1.256. If you are going to calculate this, you are going to get the value of A, which is 6.07 kilonewton. And as we have assumed, the force of 2A is upward, that is the normal force. Here, we are applying the concept of summation of forces in the y plane should equate to 0. So f of y is equal to 0. 2a and 2b are upward. So 2a plus 2b. Meanwhile, the weight of the cartons and the weight of the truck is downwards. So minus 2w, as there are two cartons, minus weight of the truck. As we previously know, the value of A is 6.07 kilonewton. Now we are computing the value by equating this to 0. So 2 into 6.07 plus 2b. The value of b we are supposed to find out, minus 2 into weight of the carton, that is 3.4335, minus the weight of the truck, that is 13.734, equals to 0. On solving this, we'll get the value of B to be 4.23 kilonewton. Thank you. So we'll find the moment about point B.